Hello, everyone. Sean, Tiara, Anasa, Celestine, Jasmine, and Lacey. Okay, it's a 5, and some of you email me wanted to know where your midterm exam made a mistake and what's the correct answer. If you are one of them, I can go to check out the midterm exam and the problem you got the trouble with. Anyone want to review your midterm exam? Oh, yeah. Oh, okay, it's right here. Okay. Got the one. Oh, that's not the one. Stop. Share. Share again. Okay, can you see the midterm exam? Question 1, question 2, question 3, 4, 5. Some people said they want to go over midterm exam. So if one of these you have questions, I can show you how to get right. So for those who are here, we can take care this one for you first. Unless you got the 15 out of 15, 100%. So you don't need, right? Or you already figured out where you made a mistake. I think it was Ginny, right?
I don't know how to pull up which ones I got wrong.
Oh, Ginny, do you know which one?
I'm sorry?
Which one you got wrong? Because you are the one
Oh,
sent
I don't know which one I got wrong. It
up.
doesn't show me which one I after the exam. It didn't tell me.
Because this is all different, right?
I don't know. That's why I emailed you because I don't know which one I got it wrong because I had not much problem with the solving all of them, and
Oh,
I don't know which one was wrong.
I see. Huh. Okay. So you don't, while you were taking the exam, nobody got the trouble? That took you time to think over? Okay.
Actually, the last question can
15?
yeah, the last 15.
Okay. Oh, that one. This is the one we call central limit theorem application, because when you read the problem, it's asking the probability, a sample. Okay, when they mention something sampling of the sample size, certain number, even sample size as a 4 or like this one 79, it's a sample. Is randomly selected. So we need to apply chapter 7 central limit theorem for this problem. So how I do it, it's the standard deviation from the population here, the $203, we need to divide it by square root of the sample size. That's very important. So I think I'm going to write it on the chart so you can see instantly what we needed to do here. Where is my chart? The chart is up here. Or let me do another way. I'm going to copy question 14 and 15. Control C, and I will bring to the whiteboard. Oh, let me use the whiteboard. Oh. My whiteboard is up here. Okay, came out. Whiteboard. So I'm going to copy those two questions, put it on the whiteboard. So everyone can see the questions and can see the work, how it works. All right. Oh, it says we are having trouble connecting. Oh, okay, finally. Okay, so you can see the whiteboard now. Let me open the new one. Okay, Control V. I just copy and paste our exam questions. Okay. So do you see the question 15 there, right?
Yes.
Okay, great. So now I'm going to show you the work. How you work out is probably easier. But first, we have to search for the keyword. And the keyword, you know, is when they mention something sample size is randomly selected. The one, there's a red line under, okay? So that's indicate we need to apply central limit theorem. Okay. So we go to apply this one.
I can't see the whiteboard.
Oh, yeah?
I can just see the quiz or the test.
Oh, you cannot see this one? Let me stop share, sorry. Stop share, then I have to try to do again. Because the computer is a computer. You have to do one at a time. You cannot skip. And now let's go to the whiteboard. Share. Can you see now? Or you just see the problem?
Yeah, I see the problems now on the whiteboard. Yeah.
Did you see I wrote the central? Did you see central?
No, I can't see your writing.
This one looks
Oh.
like just a screenshot to me.
So then that's the wrong one. Let me share again. No one, this one. Okay. Share. Can you see central?
Yes.
Yeah, that's the right one I want to show you. Central limit theorem. We need to apply this one, okay? This is from chapter 7. So what is the central limit theorem? Which says the mean of the sampling. And the mean, let's type mean of the sampling is equal to population mean. Okay. population mean. So that is given. That is given as recently mean annual cost of the auto insurance is 1,005. So that's the one, 1,005 that we need a copy over for the mean. And the standard deviation is the key. You need to do adjustment. Standard deviation of sampling. It's not exactly equal to population standard deviation. So what we do, we need to divide it by square root of the sample size to do adjustment. So we can use population. I will just type population standard deviation. We need to take this number divided by square root of sample size. And this sample size here is 79. So that's the number you need to type in there and divide before we looking for the probability. So most of you, I believe, you know how to use your TI-8384 calculator already. When they ask you, looking for the probability, the sample mean greater than $1,000, what's the probability or the chance we get that when we do sampling, okay? So what do we do? When you go to the graphing calculator, first, we need the second vowels, right? You have to type in second VARS. So if you have graphing calculator, you should do it. Second vowels, then you will select normal CDF, second one, normal CDF, okay? That's the second option. And after you select that one, you need to enter, right, the data. So we select the second one, enter, and my calculator is TI-84, so they allow you to do step by step. What's the low bound? What's the upper bound? And the low bound, sometimes they give you the -1 equal to the 99 power, like that one. But if you don't have that one, no worry. You can just type in with a -1, okay? Negative sign in the front. Last time, someone in the class did not use a minus sign inside the parenthesis. So that's why all your TI calculator couldn't work. Because we have two minus sign here. One is for subtraction, the first row. And the minus sign is the second row. You need to come to the second row here, second column here, the bottom. The one inside the parenthesis. And you can just type a 9999, some bigger number. That means, oh, this one is greater or equal, so I'm sorry. Greater or equal is the starting point is 1,000, so you just type in 1,000, right? And upper bound is up to where? We want the greater than 1,000, so upper bound will be infinity, okay? Very great number. So you just put a 9999. That way work, just a larger number. So starting 1,000 and upper bound to the 9999 because greater. You don't go to the end on the right hand side there. Then the mean, you will type in the number given to us here, 1,005, right? And the standard deviation, I will use this symbol here. Actually, it's a sigma, that we call sigma, okay? Sigma, it's given as 203, right? So your 203, you cannot just input the 203 only, okay? 203, you need to divide it by square root of sample size, which is 79. So if you follow this input here, The lower bound is 1,000, and because the greater than, that means the minimum number, the price, right, is $1,000 to, we don't know yet, because greater than $1,000. What's the probability greater than $1,000? So if they did not give us the ending number, we just put a very great large number. You can type a 4 of the 9, okay? And the mean is 1,005. Standard deviation I type in already. And apply central limit theorem, divide by square root of the sample size is 79, okay? Then you go to your calculator, you just type in 105, okay. And this is 203 divided by square root of 79. Then go to paste and hit enter again. You should get the answer already, right? The answer is, will pop out 0.5866. Did you get that? 0.5866. And there's more decimal behind, but we just round off to 4 decimal, okay? So if you have seen this type of the problem again, you have to remember apply central limit theorem, and the key is that the standard deviation needed divided by square root of the sample size, and that's all. And the lower bound, upper bound, you greater than, just starting that the number give to you and to 99999. You less than, that means go to the negative infinity there, right? So you need to add the minus sign in the parenthesis for your lower bound, okay? And if the question is in between, that's easier, right? You can just type in what's the lower bound, what's the upper bound, okay? And for this one, we should do this way to get done. And if you use the TI-83, 84, it's very quick, you get done, okay? Because all this one calculated with computer for you. You don't need to do a calculation, round the G-score to 2 decimal, then go to the G-score table and searching for the probability. And so sometimes we can make a mistake during the process. But using a technology, it's much easier. Okay, 1,09999, comma. For TI-83, just need to type in like this, 1005, comma, and the standard deviation, 203 divided by square root of sample size 79. And enter, right? Enter, we give to you. And for TI-84, they separate lower bound, upper bound, mean, standard deviation like that. But for those who still use a TI-83, you need to type in. Okay. Okay, so that's for the question 15, application of the central limit theorem from chapter 7. And some people make a mistake on the chapter 14, the question 14, just because didn't read the problem carefully. This problem is asking you to find the IQR, not the 5-number summary. I saw some people put a 5-number summary, those 5 number, and of course it's wrong. They ask IQR, okay? IQR, you had to find the Q3 and subtract the Q1. The answer is 14. So that's what the common mistake. All right. If no more questions.
What does IQR mean?
Interrange quartile. The difference, the range between Q1 and Q3. So you just need to use Q3 minus Q1. Right. That's from chapter 2. So IQR, oh, you know, type. IQR equal Q3 minus Q1. I is interrange. Q is quartile, right? Interquartile range. Okay. Any other question you have? I can stop share of this one. Then you can look at the question again. So we can stop share and share another one. Share the exam questions. Okay. Share. So now you can look at the exam questions more. Let me see the common mistake. Start from one. Number one, let's start from the number one. The number one is looking for the median. So most of people got right, but some people very careless, just jump in and pick up the middle number 31 and you think that's the answer. When we choose the median, we need to sorting the data in order from the smallest value to the highest value, right? So you have to rearrange the order here, starting 15, then 21, then 31, then the next one is a 40, then 65, 71, 82. So actually the median is 40, not the 31. Okay, so I saw some people chose the 31, and that shows that the person forgot to rearrange the order of the data in order ascending, right? And number two, standard plot. I think most people know how to read this, right? From the same number, then pick up the one digit each time from the leaves, like a 76.3, 76.5, 76.8. That's the three data there, right? And then for the standard 77, you will pick up one number from the leaf again. 773, that's another data. 774, 778, another data. Same thing for the 78. 78, match with a 1, so it will be 781, one data. Another data, 788, the last data. That's how they do. Most people got right at this one. But let's see, this one try to find the mean. And try to find the mean of the frequency table. This we call frequency table, right? We have 1, 2, 3, 4, 5 classes here. And frequency is a student. How many students got the score? Between 50 to 59, we have 5. And 60 to 69, we have 8, right? That's how you read here, frequency. So since our frequency table is given in range of the score, did not give us the detail for each student, what's their exact score here. So this kind of distribution of the data, you need to take a 50 plus 59, add up, divide by 2, right? Take the average of the each range we have, each class we have here. Then like a 50 to 59, when you take a 50 plus 59, it's a 54.5. So you need to take a 54.5 times the 5. Use the average as a representative score times the number of the student. Then adding the second class will be 64.5, multiply 8 students, right? And similarly, we do the same thing for all the 5. Then add them up, then divide by total number of the students. And total number of students just have to add up. All the students is posted here. That's would be total number of the frequency to get the average, right? Let me see any other one. How about the question 7, the game? You have 1 out of 99 probability winning the $500. and 98 out of 99 probability to lose the $30. Okay, what is your expected value? So for this type of the problem, you have to remember this is applied to the game. That's what we call expected value. But actually, we try to calculate the mean, same idea. But the one thing you have to pay attention is winning the money is a positive $500 times the probability. That's fine. But probability to lose the money, losing the money, we cannot use the same positive. You have to think of the algebra. Something you lost, you have to use a negative, right? So you have to use a minus 30 times 98 plus 99. Then add them up. That's the mean, right? That's the expected value. So and for problem number 9, I will say someone couldn't do this one because that the person didn't know how to find the small p, the probability for one trial, right? And this problem said we have 4 possible answers. That means each question there's A, B, C, D, 4 choices. And to get it correct, it's a 1 out of 4. So it's a 0.25. Okay. So you need to be able to think of that. 1 out of 4 is correct only. Then take a 0.25, multiply 20, and that's the mean, right? N times the P is the mean. Okay. And 11 is a standard deviation. We just need to do N times the P times the Q. Then take a square root. Okay. All right. So if you don't have any more questions from the midterm exam, we can move on to take care chapter 5, chapter 6 now, right? And no, chapter
Can
8,
you go over 13, please?
chapter 13? Sure.
Number 13.
Number 13, okay. Number 13. Okay, let me copy, Control C. Then I move to the whiteboard. So small. Come. Huh. Okay. Let me stop share, another one, and come to the whiteboard. Share. Okay. No, come on, so small. Anyway, I just want to show you the work. So, may I have data? You read earlier, the problem is asking you the length of the professor's class. It's a continuous uniform between 50 minutes to 52 minutes. And they ask you to find the probability that the class length is greater than 51.5. So what we needed to do is the probability of random variable presenting by x. We wanted the time, the class length is greater than 51.5. That's the question is asking you to find out what is probability of this one. Okay. So it's a uniform probability. The keyword is that word of the uniform, right? I don't know how come it's so small. Couldn't show you. So the keyword, you have to remember the keyword. They mentioned this is a uniform. Uniform distribution, right? So that's give you the idea. We need to use the area to calculate the probability. So you have to use a rectangle area, okay? Because uniform means all the chance will happen between the 15 minutes of the class time to 52 minutes of the class time. Every different timing of the length here got equal chance will happen here. Make it a straight line on the top because we want to use a rectangle to prove we can use the idea of the area to calculate the probability, right? So we kind of we need to think of a rectangle like this. Single rectangle on the top is uniform probability, the chance for each one, okay? So the horizontal line is try to put our time, right? Time. So the beginning point here, you need to type in 50 minutes, right? So I will type 50 minutes. And the ending point here, these are ending points. Not make it bigger. The ending points, are we supposed to type in 52, right? 52. Wow. Typing in 52. So 52 is the end of the rectangle here. And the first thing you have to do is to find out, because we are going to use the area to find out the probability. And question is asking you 51.5. So you can draw, sketch one rectangle, then point out where is about the 51.5. So 50 is here, 51, 52. 51 is in the middle here. And 0.5, maybe a little bit more here. Okay. So you can mark down that the point we wanted to find out, the 51.5 minutes. Okay. So draw the section. This is what we are looking for. Greater than 51.5, this area here. Okay. So if you recognize just this small rectangle area here, I put a red line now. You just need to use the idea from our geometry. That the area is equal to the length and multiply the length multiply with the width from geometry. Okay. So compare with that rectangle, we need to find out we are looking for the length will be the base part, the bottom part in this small rectangle here. So you just need to do what? The probability. So we can give the answer already. The probability of x greater than 51.5 is equal to the base length is 52 minus not 51.5. That's the bottom part of this base. Then you just multiply the height of the rectangle. And the height of the rectangle is, you have to assume what? Total area as 100%, right? So you will do here. And to find out the height is like width of the rectangle. You just need to take a total area, right? Take a total area divided by W, by length will give you the W. You can think from here. To get the width, the height, I can just use the area divided by the length. Divide, will give to you. And for statistical probability application we do here, we take the total area of the rectangle as 1. So take a 1 divided by the length at the bottom here, right? And the total length here. the interval. So it's a 52 minus 50, right? So you just take a 52 minus 50. That's what give you the height of the rectangle. And multiply out, that will be the answer, right? The first parenthesis is just a 0.5. And multiply the second parenthesis is 1 divided by 2, right? And 1 divided by 2 is 0.5. Same thing, 0.5. So 0.5 times the 0.5, the answer is 0.225. Okay. And then you look at the picture, that's about 1/4, 25% of the total area. That's correct. And are you working on the chapter 8 already? Because after the midterm, we had to move on to chapter 8, right? Then chapter 9. So, if you don't have any more question from the midterm exam, we can move on to the chapter 8. And if you still have question here, you can tell me which problem you'd like me to show you. Okay. Any more questions from the midterm? Okay, it look like no. Then let's move on to the chapter 8, right? Now we have to focus on our second part. Actually, for the final exam, I will just focus on chapter 8 to 13. I will not just ask you the question from chapter 1, chapter 2, or 3, 4, 5 to the 7. No. I will take this first part as your prerequisite. You learn something already. You know what is the probability and what is the discrete random variable, what is the continuous random variable probability. And then that is your prior knowledge you got to have there. Now we do final, just focus on chapter 8 to the 13. Okay. You will see by the final exam, a week before the final, I will post the review questions again. You will see all those review problems are from the chapter 8 to chapter 13. Okay. So, of course, what we made the mistake before, we need to make a correction, right? Then we need to focus on what is going to be our next exam now. So that chapter 8, I think we go to chapter 8. Let me open the page. Chapter 8. If you use your TI 8384, it's very simple and easy, except 3 things. Except 3 formulas that we needed to do by hand. Because 3 formulas they did not program into any computer software. Neither this TI 8384 nor the computer software like GeoGebra or SPSS or any other computer software. They don't put in because I think that's because there's some problem critical value found in that. So maybe I can help you that one. Okay. Chapter 8. So let's go to chapter 8. Maybe chapter 8, the homework. So did you see chapter 8 now? Yeah? Okay, good. Chapter 8, we have 2 types of the confidence interval. At the beginning, we need to know, which is how can you find out the estimation for the population mean? Okay. Starting chapter 8, we are doing kind of backward. Okay. Before the chapter 8, we kind of given the mean and ask us to find out a probability or some other information here. But starting chapter 8, we are looking for parameter. We are looking for like a mean of the whole population. Or the population proportion, right? For the whole population. So for the mean, first, you can look at your homework exercise here. The first two, the first one is for the mean, population mean, looking for population mean. And population mean, you have to be careful. One thing here, that it's population standard deviations given or not. Okay. Like question 1, when you read the problem, it says sample size 32, sample mean 46, sample mean equal x small x equals 6. When you see the small x, that means we only have sample standard deviation only. We do not have whole population. Okay. And even the past research, we only have sample standard information from these 32 data. So problem asks us to construct one confidence interval to estimate at 99% of the confidence level. And this confidence level, usually we use 95%, 90%, or 99%. These 3% are very popular we are using, okay? And each one, we have some critical value. So what is a critical value? It's kind of like a boundary, bounding our confidence interval. We need an estimate from low bound to upper bound. We cannot just give you one number. We cannot. So in statistics, you're always providing one interval. What's the lowest number could be? What's the highest number could be? And give the estimation of that. Okay. So that's why look at your first homework question of the chapter 8 here is ask you to find out the interval. Not the mean, population mean is between the lower bound and the upper bound here. Okay. So to do this type of question, when x is not it's given only, small x is given, you need to remember, use a t interval. We have two types of interval for the estimation of the mean. One is a z interval. That's when sigma is given, population standard deviation is given. If that is not given, only small x like this, I have to use a t interval. Okay, you read the chapter 8, you will see there's two types. Okay, g interval, t interval, and the g interval is assume we know the past standard deviation, so we can estimate using the normal distribution. G interval is for normal. And the t interval, because we don't know in the past, is it normal or not. And we only have sample standard deviation x here, that we had to use another type of the distribution model. That's what we call student t distribution. That's a type of the graph is a little bit sharper and a longer tail. Okay, similar to the bell shape, but is not as rounded as a normal distribution, and the two tail is longer than the normal distribution because we have more error could occur here. Okay, so for this problem, I will use a t distribution. Okay. And you just need, I will select all different ones for showing you. So for this one, when I go to my calculator, I will just go to state and move on to test. Okay. So remember to go. Let me find the chat. Because the chat look like easier, I can type it right away. Okay, the chat, I don't need to change the screen, right? So go to the chat there, I will type in. So if X is given only. Okay, X means a simple standard deviation. You have to use T interval. This is the key. Okay, so when you look at your calculator, how can I reach there? You need to go to test stat and go to test. Then you select from here. You select the T interval, and T interval for my calculator is the number 8. Option 8. You will see T interval. Use that one. Okay, it's much easier. So when I use the T interval, okay, I just need to input the data, right? So I will go to T number 8, T interval, and when you come to the T interval, you will see the calculator shows this input of the data or stats. So you have to decide, okay? For input here, if original data is given, you will input the data, but not here. You have to input under the edit, okay? And for this one, we don't need to use the data. We use the stats because X bar is given. So that's the key. When you see X bar, X with a bar on the top, right, equal 46, it's given. So because this is given, I will choose a stats. Okay, stat. That means a statistic. Okay. The measurement of the sample we already given here. So you will highlight on that one and just enter X bar for the number given to us, 46, right? So I will go to the 46, then go down to simple standard deviation, XX. So XX, they type in as a XX subscript. So you just need to enter that number. Another number is given as 6. Then type 6. Then go down to the sample size. You always have to provide what's the sample size. And the sample size is given as 32. Okay. So 32. Then go to the C level. That's a confidence level. Okay. When you see C level, which means confidence level, C level. Because in statistics, we only choose the level to estimate. Okay. And that means 90% confidence, or 95% confidence, or 99% confidence, or some problem maybe 80% confidence, like that. So you just provide that number. And problem said 99%. So you just type in 0.91 and 0.99. 0.99. Right? Put the 0.99 and you just go down to calculate. Right? Calculate. And enter, right? And the answer will pop out right away after you hit the enter. Then you will see the screen will pop out 43.09, comma 48.91. Okay. And that's the answer already. Okay. The graphing calculator give you in parentheses. Okay. And our question here is ask you to use the inequality symbol. So inequality symbol, you just have to put the low end on the left-hand side and put the mean. We are estimation for the whole big population mean, the mu, right? The mean, okay? And in between this number, we got from the graphing calculator, 48.91. This is the upper bound. So the true population mean is in between these two numbers that we can provide to the people. Okay. And so this is the one. And if another type of equation, if they give you the sigma equals 6, then you should use the G interval. You look at your calculator, there's a G interval. G, normal distribution, only when sigma is given, only population standard deviation is given, okay? And If not, you just use t interval. And in the real world, most of the time we use a t interval. But most of the time, when we try to estimate something that, for example, we try to estimate how many pieces of the new iPhone is sold, and we did what were sold here, and we didn't have it's a new iPhone. We didn't have past standard deviation to calculate to estimate here. So therefore, for the new product, the new things happening, most of the time we have to use t interval because we can only use collecting the sample size, interviews 60 people or 30 people and collect their information and find the standard deviation from the sample only. So you can only get from the sample only, use the t interval. Okay, that's very important to remember that. And one thing I want to share with you is question 2, because some question ask you the critical value. And the critical value, of course, you can read the table, okay? We have G-score table, we have T-score table, and all this table is on the last page of our digital textbook there. They provide a link for you to find the table. Or easier way, you can just go to the Google, right? And type in T table or G table. Pop out the table, and you can select the one much easier to read it. Okay, actually, I always use from the Google. I don't use the one in the back of the book anymore because a lot of people make something very fancy, very easy to read, much better. But after I have the graphing calculator, I don't use that table anymore. After I know how to use the computer software, I don't use it anymore because you can use computer software to help you, or you can use our graphing calculator, handy one, to find that answer. So I'm going to show you how I use the TI-84 to find the critical value. We started reading that small table and all the number very small. And sometimes from that table, you can also find that answer because the table is, I think, they came that the table is 100 years ago, probably. And that's a very old one already. And the number is very limited. Okay, we better use a new way, use your technology to find. So I will do the problem number 2 now. Okay, so problem number 2. Let me see. Can I open? Yeah, I can use the chart here again. Okay. So you can read the problem and see my work from the chart. So the question 2, this is sample size of 76. Okay. And we intended to estimate population mean with a confidence interval and find the critical value that corresponding to confidence level of the 99.9%. Okay. So I said earlier, critical value is like a boundary, bounding the 95%, right? From lower bound to upper bound here. If we want to provide the 99%, then again, you need a low number to upper number, right? Lower bound, upper bound. So that the critical value is that bounding number, okay? At each level, there's different number here. So how can I find this 99.9%? Well, first, we need to do some drawing, okay? But it's 99%, okay. Maybe I need to use a whiteboard because I need to do some drawing to help you to understand this. And once you see one, so you can do second one yourself. No more questions. So let me use, I'm going to make a drawing of this. So I need a copy. Yeah. I want to copy this one. Okay. Control C. I'm going to bring over to my whiteboard. Control V. Then stop share. Then share again. Whiteboard. Share. Okay. Can you see this one? Question 2?
Yes.
Yes, right? Okay, great. So now I'm going to draw something, okay? And I'm using my mouse to do the drawing, okay? So it's not too great. And, okay. I will make one horizontal line. And this, they already said this is a T distribution because they use T here. When you see the T, that means they use a T distribution. That means they do not have whole population standard deviation information here. And that's the notation of the alpha divided by 2. Alpha is a significance level. And why we divide by 2? Because we put each side, okay? So I'm going to draw some graph here. So T distribution look like this, okay? On the top, it's not rounded like a bell. Bell is more rounded, right? This is not. And the tail, left tail, right tail is kind of longer compared to normal distribution. So let's divide here the tail. That's what we call tail. Okay. In statistics, we always like to use this word of the tail. Tail. Okay. So the right side here, then the bounding area here, this area, I'm going to shading area, shading each side here. The two tail area is the one we call alpha divided by 2. Okay? So when you see the notation, you understand what is that now. And what's the alpha? Alpha just the one we define, we call significance level. And this alpha is coming from Greek again. Okay? So alpha presenting significance level. And what does this mean? It's the area to the tail, to the right side, left side, because they are inflecting the probability, the chance will happen, the score very high or very low, right? You can imagine our exam. After our midterm exam, we have majority of people is stay here, close to this high point here, the average here. Majority is 80% around. 85, 86, 85 here. And who got the 90 or 100, not many people. That's the one of the on the right side here, the frequency area here. And the other side is the people who didn't do well, like got the 50%, 40%. We only have maybe about 2 or 3 people only. And because they were absent many times to do their work. Only about 3 people there. And who got the 90% above, maybe we have about 8 people or 9, 10 people here, okay? But this is kind of tail area, side area. And this area here for the high score area, for the low score area, we call significance level, okay? And in the middle here, we call confidence level. Confidence level is in the middle, majority score is here in the middle, okay? 70 to 80%, I would say majority is here, okay? Then they ask us to find out this boundary here, right? You can see this one here. I want to find out what is the bounding here, this point, okay? We want to find out what number is this bounding here. And that's what we call T, critical value T, and with the subscript of the alpha divided by 2. Let's just tell the people here is bounding the right tail area and right side for those high score. I will imply this area for those who got 100. We have maybe about 3 people got 100. So 100 is not many people. It's rare on the right side here. And about 3 people below the 60% on the left-hand side here. So majority is here, right? Majority. So we also have another bound here on the left-hand side for the low score here. That's a T, another T, alpha divided by 2. Okay. So you can see why the problem asks you plus or minus, because the one on the right-hand side will be positive. The one on the left-hand side, this value here actually will be negative. Okay. And it's asking you to find these two numbers. Okay. So confidence level is in the middle here. Okay, in the middle here. In the middle here is 99.9%. And you need to change this one to 0.999. Change it to the decimal. Okay. Then, because we need to calculate what's the tail area here. Okay. And the tail area, you need to take 100%, right? Or use a 1. Use a 1, subtract 0.999. So will give me the tail area should be, right? You will get the 1001. You get 0.001, right? But 0.001 is 2 tail area together. That's the alpha, okay? So our alpha, actually this is the alpha. This is the alpha. Alpha equal this one here, okay? And we need to take alpha divided by 2, right? Like this one here. I need to do here. I need to change this one to using the 0.001 divided by 2 to calculate the area. So which is when you take a 0.001 divided by 2 will be even smaller, right? 0.001 divided by 2, you will get what? 0.0000030, all right? And 5, right? We give it a 4 decimal. So your calculator maybe shows you 5e negative 4 power. Let's just try to tell you 8 on 4 decimal. So you will come out the 0.0005. Okay. And when you find that the tail area is 0.005, you just need to enter your calculator here, okay, because that's what we need. Our bounding area. What's the area? So what do you do? Now go to the your calculator and do second vowels, right? Second vowels and select inverse. No, inverse. Oh. Select the inverse INV and with a T. Okay, inverse T for the T distribution. Okay. And so I will select the number 4, enter. And the screen will pop out. Ask you, what's the area you have here? You bounding here. So you can type in this 0.0005, right? And 0.0005. Then they ask you degree of freedom. When you see DF, right? DF, that means the degree of the freedom. So I need to explain this one too. Degree of freedom is defined as n minus 1. Sample size subtract 1. Okay. Why we need to do this? Because we are using the simple standard deviation only. We do not know anything on the sigma. So that's population standard deviation. Sigma is so important here. If it's unknown, we have to use everything more conservative. So sample size, you need to subtract 1. That's what we call degree of the freedom in statistics here. So in your calculator, you don't type the n minus 1, okay? I just explained to you that's equal n minus 1. But you are not going to type this one, okay? This one just my explanation only. You will just do your work, take the n, put the n here. The problem said you are estimating simple size 76, right? So you just do 76 minus 1, which is 75, right? So you need to type in here, degree of freedom, use a sample size, subtract 1, which is 75. So I will input the 75, then paste, and enter. And hit the enter, will give you the answer right away as inverse. Okay, no. So you will come up inverse P with 0.0005 and comma 75 degree of freedom, right? And hit the enter. When you hit the enter on this one, you will see the answer. Okay. Oh, I think I need to bring this up below. Okay. So the answer, if you follow me, your answer should come to negative 3.425. And I believe they want you round to 3 decimal places. So that's a 3 decimal, negative 3.425. So you will say, how can I count the negative? Because we got the answer for the negative side on the left-hand side here, okay? And left-hand side is negative. Okay? So this position here, that one is 3.425, okay? And right-hand side is a positive 3.25. If you want to get the answer, give you the positive here, you need to take the area to the left-hand side of this critical value. And that means you need to input differently. You need to input inverse P with 1 minus, okay, you need to take total area 1, subtract the 0.0005 and give you the 0.99 0.9995, right? Comma, degree of freedom 75. You use that way, you will come out the positive, okay? You will come out the positive. If you input this way, you will have positive, for sure. You will come out the 3.425. Because the area to the left, right, is 1 subtract this small area here. This small area here is 0.005. This is 0.005. And this is 0.005. And calculator require area to the left. Okay, so that's fine. You need to do that. So you can try out. When you put the second vowels, inverse T, and input the change to area to the left as 0.9995. And degree of freedom, same thing. You should come out positive critical value, okay? But our answer just need the input here with the 1 absolute value symbol, like 3.425. They already put the sign outside, plus or minus. So this will give you the understanding why we have plus or minus, okay? So I think the more difficult problem is this one, because every semester I have students put on the discussion board to ask me these questions. How can I find the critical value? The table doesn't show it. And I don't know how to use the calculator to get it. So that's how we do it. Okay. Use inverse T.
I have a question.
Yes, please.
Okay, this is I don't understand this part. If
You have to
we're
read the
looking,
section first. You have to read the chapter 8. Without the reading,
I did. I just have a question about the equation with the tail.
tail,
Because
the tail.
if we're looking for 99.9%, why
It's
do we
inside.
only include one tail and not both tails in the equation? Like, why do we divide it by 2 to only include one tail? Right? Because wouldn't the remainder on both ends
Okay. Tell
be
me,
the exemption of the 99?
99.9% is in the middle.
Yeah.
So how many tail we have?
2.
Yeah. So you need
Don't I want information from both of my tails? Because won't that exclude the middle? It will leave me with the end, and the end is what I'm looking for, yeah?
yeah.
But we cut
So
that
you
in
need to
half. We're only
figure out the
one
one.
tail.
So you have to divide by 2 to get one tail. Because the calculator designed that way. You have to
It's a okay, if that's
Yeah.
okay. Because
You have
my
to
brain is
provide.
like, I want both of those tails in my equation, and so I forget
You
that part.
cannot.
Okay.
The programmer, they define that way. They need to find out one tail only. And so one tail, like this tail here, I need to find out this one first, right? Which is divide by 2 to get another number, small number, 0.0005, and to find out this negative number. And if I want to find the right tail, I have to put the 0.99995, all the area to the left. The middle one plus this tail one, that's why it's 0.99995. Or you can use the 1, subtract the right tail. So that's why I use the 0.99995. That's a programming. They only use the area to the left. Yeah. It's just the way they design that.
Thank
Good
you.
question. Good question. Maybe one day you can design something into the 2 tail and give you the answer. That would be great. Save it all time. Any other questions? So everybody, you have to read chapter 8, okay? A1, I believe A1, A2, A3. Let me see how many sections you need to cover. This is your physical book, statistic, okay? This is the one we are using, introductory statistic. But they give the student a free digital copy. I give the teacher 1 copy only. And some teacher even had this. And they they just say, you had to order, you had to pay the money to get it. So for the chapter 8, we need to cover A1, A2, A3, right? 3 sections. Okay. So try to do this, and next time when I see you, maybe I need to help you to do proportion when you have question on the proportions. Okay. And proportion is a very useful tool for the election. I remember the time election of the president. I watched the TV that time many years ago when the president Obama was elected that time. I watched TV, CNN, MSN, and they really used our confidence interval to estimate how many percent people were voted for certain candidate. And they estimate 52% people were voted to Obama. It really happened. That was amazing. So I never forgot. So they really use statistics. Okay, so it's time already. She's 13, right? And try to do however you can. If not, put your questions on the discussion board. I will go there to answer your questions as well. Okay. And hope to see you again on Wednesday, right? Next week. And don't go away yet. Because I need to check who are here. So I need to see your name here. I'm going to, okay. Some people left, huh? But however, I will copy all these people the name first. And I know Sean was here earlier. Okay. Because some people needed to go another class, they told me before. So before the 6th, they already left. Okay. So I will copy this name first, then I add the name of the people. And so I will see you next time, okay, next week.
Thank you.
You're welcome. And okay, so we stop share so I can say goodbye to you. Bye-bye.
Thank you.
And if you have any more questions, just email me, okay?
Thank you.
You're welcome.
Bye-bye.
Bye-bye.